right, class, let's go ahead and start section 10.2 where we talk about exponential functions. So, an exponential function, okay, if a is greater than 0 and a doesn't equal 1, then an exponential function with base a is written f of x equals a to the x, okay? So let's take a look at this exponential function. It's exponential because now the variable is the exponent, okay? And let's solve the following. I have 2 to the x, in this case my x is negative 1. 2 to the negative 1, do I like negative exponents? No, so I'm going to put that into a fraction. So f of negative 1 is 1/2, as we see right here in our graph. Let's write in a more joyous color, shall we? So if I have f of 3, that's 2 to the third, right, because I'm plugging in for x, and that gives me 8. If I have if I have 2 to the 5 halves, remember I can rewrite that as the square root. I can rewrite that as 2 to the 1/2 to the 5th, which is the square root of 2 to the 5th, which you would have to approximate in your calculator. It's like right around right here, 6-ish. So that's what an exponential function is. So when I have an exponential function, the points, when x is negative 1, y is 1 over a. When x is 0, y is 1. And when x is 1, y is a. These are always on the graph. Why is that? Let's find out. If I have f of x equals a to the negative 1, that's going to turn it into a fraction. If I have f of x is 0, that's going to be a to the 0. Well, anything to the 0 is 1. And if I have a to the first, that's just going to give me a. Okay? If a is positive, then it's an increasing function. If a is negative, then it's a decreasing function. Okay? Our x-axis is a horizontal asymptote, right? Because if I take this to any exponent, it can never be 0 as long as a doesn't equal 0. Our domain is infinity, and our range goes from 0 to positive infinity. And exponential functions are always 1-to-1, so they have inverses, which we'll talk about later on in this chapter. So let's go ahead and graph the following. Let's pick a couple values for x. Let's pick when x is negative 2, 0, and 2. So if I have 2 to the negative 2, that gives me 1 over 2 squared, which is 1/4. If I have x is 0, that gives me 2 to the 0, which is 1. And if I have x is 2, that gives me 2 squared, which is 4. So I have when x is negative 2, y is 1/4. When x is 0, y is 1. And when x is 2, y is 4. So here's the graph of my exponential function. Notice that it never crosses the x-axis. My domain is from negative infinity to positive infinity, and my range is from 0 to infinity. Let's graph another one. Let's take a look at when x is 1/2. So I'm going to take a look at when x is negative 1, 0, and let's take a look at 2. So if I have 1/2 to the negative 1, that means I have 1 over 1/2, which is 1 divided by 1/2. So 1 times 2 over 1, which is 2. 1/2 to the 0 is still 1. If I have 1/2 squared, that's 1/2 times 1/2, which is 1/4. So I have when x is negative 1, y is 2. When x is 0, y is 1. And when x is 2, y is 1/4. So you can see it's now descending, it's going downhill. My domain is all real numbers, and my range is still from 0 to infinity. Now, this one's a little more complicated, right? Instead of having just an x as my exponent, I have 4 to the 2x minus 1. So let's go ahead and solve this bad boy for when x is -1, 0, and 1. That tells us the shape of our graph and what's going on. So if I have 4 to the 2 times -1 minus 1, that gives me 4 to the -3, which is 1 over 4/3, which is 1 over 64. If I have x is 0, that gives me 4 to the 2 times 0 minus 1, which is 4 to the -1, which is 1/4. If I have x is 1, that gives me 4 to the 2 times 1 minus 1, which is 4 to the 1st, which is 4. Let's do one more. If I have x is 2, that gives me 4 to the 2 times 2 minus 1, which is 4 to the 3rd, which is 64. So I can kind of guess how to graph that. I have when x is 0, y is 1/4. When x is 1, y is 4. And when x is -1, y is like -64. So this one grows really, really fast. There we go. Now, an exponent equation is an equation that has a variable for an exponent. For example, 8x equals 16, okay? To solve these, the first thing we want to do is write each side of the equation with the same base, right? 8 is 2 cubed, 16 is 2 to the 4th, so I'm going to write them with the same base. And then if necessary, we simplify those exponents. Now what I can do is set the exponents equal to each other, okay? So I set 3x equal to 4, and I find that x equals 4/3. So 8 to the 4/3 equals 16. And you see that I worked that out down here. I pulled out the 4, so I have the cube root of 8 to the 4th. The cube root of 8 is 2. 2 to the 4th is 16. So let's go ahead and solve this. I need to rewrite 25 and 125 with the same base. So 25 is 5 squared. So I have 5 squared to the x minus 2. And I have 125, which is 5 cubed to the x. So I have 2 x minus 2. I need to go ahead and distribute those. So that gives me 5 to the 2x minus 4 equals 5 to the 3x, because I would multiply our exponents, right? I can now set these equal to each other. I now have 2x minus 4 equals 3x. I subtract 2x from both sides. I get -4 equals x. So that's our answer. Now I have 4x equals 1 over 32, and you might be saying, oh gosh, Ms. Miller, this is a fraction. How am I supposed to do this? Well, remember, if I have 32, 32 is 2 to the 4th. And fifth. And when I have negative exponents, like 2 to the -5th, that would be 1 over 32, right? I put it as a fraction. So 1 over 32, which is 1 over 2/5. 4 is also base 2. So I have 2 squared to the x equals 1 over 2 to the 5th. But let's rewrite this as 2 times 2x equals 2 to the -5th. Now I have 2x equals -5. Divide both sides by 2. X equals -5 halves. Okay, making things complicated. Now we've got two fractions. So I have 3x to the 4th is 16/9. So this is like 3 to the 1st over 2 to the 2nd to the x equals 2 to the 4th over 3 squared. Now here's the thing. These are like opposites. I think I factored too far. Let me restart this, guys. So, redo. I have 3/4 x equals 16. I want to rewrite that with either a 3 or a 4. So I'm going to write that as 4 squared over 3 squared. That's the same as 3/4 x equals 4/3 squared. Now 3/4 and 4/3 look really, really, really similar. Remember that if I had 3/4 to the negative 1, that would be 1 divided by 3/4, which is 1 divided by 3/4, which is 1 times 4/3, which is just 4/3, right? So this is actually to the negative 2. I have 3 over 4x equals 3/4 to the negative 2. So I set my exponents equal to each other, and I get x equals negative 2.